Right. Well, good morning or good afternoon, wherever you happen to be, and welcome to another RISB Masterclass webinar. Today is about a systems engineering approach to standards, which will be presented by Jackie Newbegin, the Signal Standards Lead, the Victorian Infrastructure Delivery Authority. But before we start, just like to acknowledge the traditional custodians of the lands where we meet today, and for me in Adelaide, that's the Kaurna people, and to pay my respects to their elders, past, present, and emerging, and extend that respect to any Aboriginal and Torres Strait Islander people who might be with us today. Just a quick introduction of Jackie. Jackie's an experienced engineer with over 30 years experience in the rail industry. Her career started with programming train control systems with Westinghouse, who later become Invensys and is now Siemens. She was then given an opportunity to move into safety assurance and systems engineering, where she was able to contribute to the delivery of some fantastic projects and products. Coming full circle, Jackie returned to the world of train control systems, amongst other things, with Public Transport Victoria, helping to shape the high capacity signalling specification for the Melbourne Tunnel project. She's now been given an opportunity to be part of the Signalling Strategy Task Force at the Victorian Infrastructure Delivery Authority, and to rewrite Victorian signalling standards to provide a better statewide user focus outcome. And just a reminder before I hand over to Jackie, you can put your questions in the chat, and when we get to the end, we'll hopefully have some time to discuss those questions with Jackie. So without any further delay, I'd like to hand over to you, Jackie.
Thanks, Damien. Good afternoon, everyone. Good to see everyone's really excited about standards and what we're doing. So what I'm going to talk to you today about is a systems engineering approach to standards, and which is different to what our normal approach has been in the past. I'm just trying to go to the next slide. There we go. So we're going to start with some background and context, just to tell you a little bit about VIDA and SST, where I'm from, and how this came about, what challenges we faced in starting this standards uplift, I guess, the opportunities that we had to be able to create what we're creating. And then we're going to talk about some of the systems engineering approaches. And lastly, I just want to spend a little bit of time on how RISB UK are actually doing their standards and how we're aligning to their strategy. So VIDA is a new organisation, really. We're only established on the 2nd of April this year, previously MTIA, and VIDA incorporates a number of authorities, and SST, the Signalling Standards Strategy Task Force, is part of VIDA. So the Signalling Strategy Task Force has 5 work streams, signalling standards being one of them. There's a lot of others with workload forecasting, contract strategy, competency, and a lot of them are interrelated. Obviously, you need to be looking at competency when you're looking at standards to make sure that people have the right skills to be able to, and in the right roles to be able to use the standards in the right way when you're designing. We need to make sure that the standards follow the strategy, the network strategy as well. So there's a lot of interaction. So, what is the purpose of the standards work stream? So our purpose is to update and unify all of the Victorian signalling standards and the related guidance material that there is to support like a modern way of approaching signalling. So in doing so, we're providing a structured approach, and we're increasing interoperability between RTOs. We're increasing consistency. We're filling gaps that the current suite of standards have, and we're providing clearer direction to the users of the standards in the project world. So what challenges have we faced, or are we facing still, in fact? So, how often have we heard the phrase, but we've always done it this way, so why do we change? So it's a cultural issue. So, I mean, standards have been written the same way for a very long time. So, that's our number one challenge is, how do we get people to change? Traditionally standards have been related to assets, which means that you get a nice bucket to dump everything in about an asset, but you don't necessarily think about how the standard is going to be used. So different users would need different parts of the life cycle for that asset, for example. Viriogs were written with local knowledge in mind, people having local knowledge and delivering local knowledge to deliver the signalling works. And this has changed over time because we're getting more international parties delivering stuff. We're involving more people. It's getting more complex. So, the culture has changed in the way that we use the standards and what needs to be in the standards. That's all about the culture. So we've got multiple RTOs here in Victoria, and we've got multiple and diverse standards. Obviously, we started with Viriogs about 10 years ago now, and so they were state-based, but they've diversified. They got handed over to the RTOs. The RTOs took ownership of those and updated them where they needed to. So we've got similar sets of standards for the same outcome, if you like. So we're trying to satisfy both RTOs, in this case, in a single statewide standard. Increasing system complexity. So, we've got lots of interfaces. We've got interfaces with lots of software in it as well now. So we've got lots of different types of boundaries that we need to, interface boundaries that we need to think about. So it's not just the signalling of old, which was much easier to define. There's a lot of interaction between all the subsystems of a railway system now. Requirement accountability. So I don't know if anybody's looked in a standard and looked at a requirement and says, I wonder why that was there. And I know that we've even asked people why requirements are there and they don't know. So some of that knowledge about why that requirement was there has gone with the people that have put that in there. And so, people are retiring, moving on, they can't remember. So, we're challenging that that's a challenge for us, is that requirement accountability. Why was it there in the first place? We need to think about almost reverse engineering requirements to work out, well, what value are they adding? I touched on this earlier, so we're moving towards more of a software-oriented delivery model. So, we need to move towards more of a systems engineering approach to be able to manage that. And the development methodology. So at the moment, or traditionally, standards have been developed by a signalling SME. So, it's their core to their domain. They develop the standards, but a signalling engineer is not a systems engineer. Writing requirements is not necessarily a skill that a signalling engineer has. They have certainly in-depth knowledge of signalling, but not necessarily, requirements management, requirement structure, interface development, and things like that. So these are all the challenges that we're facing or have faced in trying to produce this new set of standards and this new approach. But then we looked at, okay, so what opportunities have we got? So we can now stop the diversification in the RTOs by putting together a statewide set of standards using a hierarchical approach. So what I mean is that we need standards to be at the right level for the right person. Maybe we don't need to have one standard that has system level stuff and very detailed stuff in. So we're developing a hierarchy of standards. We want to be able to focus on the users. Like, what is the purpose of a standard if not to support somebody doing something? So, a signal designer or a tester or a function tester or, or an assistant designer. All these roles have certain tasks that they do throughout the signalling life cycle, and the standards are really, wouldn't it be good if the standards help them do their job? Again, requirement accountability. So we are looking at an opportunity to be able to provide, and support each requirement with rationale and with guidance to help provide more context and value add. Like, what are we trying to do? Are we trying to provide consistency or reduce risk by this requirement? Really, if you can't provide a reason for a requirement being there, why is it there? National alignment. So we've got an opportunity to provide alignment to all of the national standards, RISB being one subset, but there's also other Australian standards that relate to the railway industry that we can align to where they're applicable. How good would that be if we could say, right, our Victorian standards align to the RISB standard in this way? There's some parts that aren't applicable because Victoria uses speed signalling, for example, instead of route signalling. And we can provide all that evidence to show how we align to those national standards. And then industry knowledge. So we can use what we've got out there at the moment and produce something that is I guess, a super duper standard based on what's out there. So we can evaluate everything that's out there with the RTOs and the different jurisdictions, from ARTC to Kiwi Rail to Queensland Rail, Transport for New South Wales, and have a look at what they've got and work out what's best for Victoria. So a lot of good opportunities there. All right, so getting into the crux of things, a systems engineering approach. So when I guess, moved into this role, I guess the first question I asked was, what are we writing standards on? So we set up a series of what we call foundation documents, which we're using as the tools for creating and updating our signalling standards. So we want to make sure that we understand why we're writing the standards, what we're writing the standards on, what are the interfaces, and who are the users. So all that information is in these foundation documents. So we've got a signalling definition document. Now, what that does is define the signalling architecture, its interfaces and components, and ensures that everybody understands the scope of of signalling, which sounds like it's everybody should understand. Signalling's been around forever, but it's interesting how many different people will tell you what's in and out of a signalling system, and also where the interfaces are in that signalling system. So it's really good to have a baseline for that, so we knew, okay, this is what we're writing our standards on. The signalling lifecycle is another key document, because in order to understand how we were going to help the users use these standards to help them do their job, we needed to understand, well, okay, in a signalling project, what are the tasks that a signalling engineer does, and how are then we going to set up these standards so that we can provide a standard that will help them do their task. So the signalling lifecycle really goes through from concept through to disposal, your traditional V lifecycle, and says, well, okay, what key tasks are done in each of these phases, and then once we understand that, who's responsible for doing these tasks in the signalling world, in the roles, and then we can use that to help us provide a scope and purpose to the standards, saying, well, we'll write this standard to help a signalling designer design the SAP, for example. Signalling glossary of terms, we wanted to make sure that when we're producing these standards that we're using the same terminology throughout the suite, so that people reading the different standards still have the same understanding with the terms. And then the last one was the hierarchy, which is, again, I spoke earlier about, we wanted to have a hierarchical approach, so that we've got, which is synonymous in systems engineering with a breakdown of requirements. So you start with a high level document, and you move down into more detailed documents which have different authors, if you think about it. So for example, we're writing a test and commissioning high level document at the moment, and like the audience for that is really the tester in charge, but then the lower level documents underneath that will be for a function tester and a verification tester. So they have a different purpose. So that's why we're putting together this hierarchy. And the hierarchy is just really a document tree that shows the relationship between each of the standards. So that's our foundation. So then the next thing we did as part of the systems engineering approach is to integrate specialty engineering, so that our standards don't just think about the technical solution, they think about how safe it is, how usable it is, what are the impacts on the environment, and are we sustainable? Thinking about security as well, to make sure that we're both physical and cyber safe. So we wanted to make sure that we integrate this because it provides a better outcome for the project. Specialty engineering has a focus on particular aspects within a system that general engineering disciplines may not cover. Now, I know that, like, with signalling, safety is kind of second nature, but some of the other things aren't. They help, I guess, provide a whole of system solution to the standard. So what we're doing is making sure that as we're developing the standard, we're and analysing the specialty engineering disciplines along the way to make sure that as the scope develops and as the requirements develop, we're mitigating any issues that have been determined by the specialty engineering analysis to, increase reliability and availability, optimise maintainability, focus on safety, optimise, the human system interaction. That comes into play quite a bit, and making sure that, as I said, that we've got security in mind as we're developing these requirements. And that's a real key to what we're doing, and which is very, very different to the way standards are developed at the moment. The other thing that I've talked about a couple of times now is accountable requirements. So got it on the slide here. We've got a table. All our requirements are going to be in table form, so that we get a unique ID to make sure that every requirement is unique, I guess, and can be tracked through whatever it needs to be, through the system life cycle, through V&V activities, and so that everybody understands that requirement is relatable to whatever project it needs to be relatable to. The requirement text is in a very simple format, and we call that this EARS format, which is an easy, sorry, I've got a frog in my throat. Easy approach to requirement syntax. Whoops. Gone too far. Sorry. Bear with me. There we go. So an easy approach to requirement syntax, which is what it means is it's just got a bit of a structure for the way that we set up requirements. And they've got requirements that have got preconditions, requirements that have multiple parts to them, requirements that are state-driven. There's a syntax for all of those requirements. And what that helps us do is it helps take out but I think the requirement sounds better if it was this way. So it takes out the opinion of how a requirement should be written. And that way, reviewing the requirement and understanding the requirements once people are familiar with them can focus on the actual content rather than the syntax, if you like. And we also have, which I'll touch on later, a requirements analysis tool, which basically is a quality check for the requirements. It checks against this syntax so that we're making sure that we do follow our own rules. The next item is the objectives. And the reason that we do this is because we have objectives as part of the, I guess, scope of the standard, to say that this standard needs to achieve these objectives, and then every requirement in that standard must link to one or more of those objectives. And that helps us make sure that we constrain the scope to the right information, because I don't know how often you've seen, but we just keep adding things to standards. We'll just add this because that's a good idea, or we'll just add that because that's a good idea. And what's happened is that certainly from what we've seen is that there is duplication of information across standards, because people haven't thought, hang on, the scope, that's part of, that information is part of the scope of this other standard. So we're providing these objectives in the standards to make sure that we are only provide requirements that are related to those objectives. And then rationale is the big one for me. Why is the requirement there? Why is this requirement needed? Why is it adding value? Is it because as I said earlier, is it because it's mitigating some risk that maybe we've identified in the specialty engineering analysis? Is it providing whole of life benefit so that we're saving on maintenance costs later, or we're saving on operational costs? So, it really makes you think about, well, what's the purpose of this requirement? Why is it there? Why do we need to constrain the design with this standard? What benefit is it giving us? And that's really key. And then guidance is really like anything else that can help the user identify with the requirement, whether it's information about how to apply the requirement, whether it's historical information about how it relates to legacy equipment, about some background about how the requirement came about. It's really up to the developer. And what we're finding is that when we're putting these out for review, our reviewers are really helping populate the requirement, rationale and guidance. They're spending more time on that to say, oh, okay, yeah, no, look, you need to put this in about it. So, that's really valuable information. And then the last thing in our table here is a V&V method, which is really, it's really just a recommended method for how to prove that you've met this requirement. And this is really there to help the designer look at, well, okay, what does this requirement really mean? Oh, and they want it demonstrated. So, okay, so I need to do this, or if it was analysed, maybe it would mean something different. And the little green box underneath that on this slide is an example from a Network Rail standard in the UK, an ETCS one, showing that they've kind of adopted the same terminology. So they've got rationale and guidance, and their topics really synonymous with the objective. So it's interesting to see that there's a few organisations that are moving in the same direction. Now onto the development toolkit. So also what we've done to be able to design these standards, develop these standards, is have some consistency in approach in the development process. So it's interesting that previous standards that I've been involved in, somebody goes away and writes a standard and then they throw it out for review. And then review comments come back and so on and so on. But what we're suggesting is that as part of our development process, that there's a few review gates along the way as part of the development, not at the end of the draft. So our development process starts with an outline. And even before that, which I haven't put on the slide, we do an exercise where we go, okay, we're writing a standard that is approximately this scope. What inputs do we need to be able to help us to do that? And we look at the RTO, V-Line and MTM standards that are applicable. We also look at any other jurisdiction standards that we might think might help, like Network Rail, Kiwi Rail, ARTC, Transport for New South Wales, Queensland Rail. Look at all those standards to see whether we could use some of their standards to help as input, as reference documents to help us write our documents. So then we have an outline, and an outline is basically a table of contents, but it also spends a lot of time on traceability. So one of the things that we're doing in order to gain, I guess, acceptance by the RTOs is show how we've aligned to all of their standards. So that obviously, as I said earlier, MTM and V-Line have their own standards on signalling, and we're trying to write a statewide standard that brings together all their good bits and I guess future strategy and direction going forwards. So we're actually providing some traceability to all of their relevant documents, showing how we align. So that's done as part of the outline too. And that's reviewed. So we look at and establish that that is a good baseline to start with, right? We've got a bit of a plan. Then we move on to a bronze, and a bronze is all about, okay, now let's using the outline. Let's start putting some requirements together and see whether we can, I guess, whether we agree with the outline still as we're developing. Which is a plan. It's a live plan. So we move around a little bit, and once we get to the end of that bronze, like we have full traceability and alignment to RTO's standards to show exactly which requirements of ours link to, trace to requirements of theirs. We have I guess, a draft bronze standard, and that's reviewed by SST, and that's an internal review. Once those requirements are implemented, we get to silver, and then we send it out for industry review. And once we come back from those, we close those out, develop a gold, and hand it over to DTP, who are the owners of the state standards. So you can see there's quite a lot of process involved in getting a standard out for review, and engaging stakeholders early is a key part of the process. So we've developed that development process over time and tweaked it as we've gone through each of the steps of the process the first time, and had some lessons that we've learned. And that provides us with a really good base for developing all of our standards going forwards. The other thing that we've done is created a design template, which a design template for us is used for all the standards that are design-based. So they're the ones that tell you what to build and help the designers in the projects design what they're building. So signalling principles and all the design standards on circuits and things like that, they all use the design template. And so this is where we get that, the objectives and the requirement structure. And that design template, before we threw the first standard out to all the reviewers, we actually walked through the template with the reviewers to make sure that they understood what we were trying to achieve. We did some tweaking, and then when they got the first standard in that form, they were at least familiar with the way we were trying to approach things. And we also have a process template, and I wanted to talk a little bit about the difference between a process template and a design template. So process standards are really about how we do things. So, and an example of what we're doing at the moment is the test and commissioning standard. So if you think about the test and commissioning, it's a way of doing things. So what we've done is developed a process template, and they, as I said, they focus on the how, and they include a process diagram that says, with steps in, to say, right, you've got, step 1, and then you do step 2, and then you do step 3, and then we get to the end of whatever it is. And then for each of those steps, there's a section within the document that talks about those steps, and the parts of that, each of those steps sections includes, the inputs and outputs, the roles that are applicable to this step, the requirements that are applicable to this step, and the rationale for this. Why are we doing this? Why have we got this step in the actual process? And the process documents also include some overarching kind of fundamentals that have requirements that apply sort of across the whole process. So we're trialling this with our test and commissioning standard, so which we're at bronze at the moment. So will be interesting when we go to silver and see what industry think of the application. They've seen the process standard template, but the application of that will be interesting, and it has been challenging. And then the traceability process, which I've kind of talked about already, is really key. So we want to make sure that we're not reinventing the wheel, that we're taking all that good stuff from the RTOs, and that will help also in getting acceptance from the RTOs. And we're also providing alignment to the RISB standards, as discussed earlier. So we're importing everything into, I'm sort of spoiling us slides a bit further down, but we're importing everything into DAWS, which is a requirements management tool, and linking everything together, which makes it much easier to see from an impact perspective, but also, it's easier to see what links to what. Right, so that's our development toolkit, and it's key, and we're actually going out to suppliers to help us develop some of these standards, and so we give them this development toolkit to help them develop their standards to the quality that we're expecting. So it is really helping us. So as I said, we're in our systems engineering approach with requirements. So if you remember, standards are really just a bunch of requirements similar to any systems engineering document, so similar to a functional specification or design specification. So we're using DAWS, which is our requirements tool, and the picture on the right-hand side there is our schema on how we're, I guess, managing the interfaces between all these bits and pieces. So you can see the Victorian requirements are in the middle, and it links to a lot of things. So as earlier I spoke about a set of objectives, so all our requirements link to objectives for that standard. So we're getting a complete set of traceability from objectives to our standard, and then the child or children of that standard, we link down to those as well. We're applying RISB requirements to our standards. We're affecting the operator requirements, so you can see that. We've got a separate interface requirements section as well to make sure that wherever we've identified that in our standard, when we've got something that interfaces to, say, a power standard, which we've done in the signalling principle standard, we want to be able to store that somewhere so that we can tell the people who are writing the power standards, hey, we've got an interface to you, so we need to make sure that we keep this link happening. Now, if everything was indoors, it'd be wonderful because we could do that via DAWS, but obviously not everybody has that, so we're just going to pass this information on to the relevant discipline in the RTOs or in DTP who are developing these other standards or maintaining these other standards that we're interfacing to. And then another interesting thing that we're doing is down sort of the bottom part of that picture, where all our causes that we're identifying as part of the specialty engineering analysis in each of those disciplines, so security, safety, human factors, RAM, and environmental and sustainability. So we're saying, right, these are the causes that lead to these issues, which lead to these consequences. So what can we do about these causes? And so we're linking these causes to our standards to say, well, we can create a requirement in our standard that mitigates this cause or partially mitigates this cause, because maybe some of it is scope related and needs to be mitigated in a scope document for a project. But where we can mitigate these causes in a standard, we're putting it in a standard and providing that link to say, well, this requirement's there because it mitigates this standard, this particular cause for safety or for human factors, which gives more substance and more rationale to the requirements. So we've got quite a complex DAWS management system now, and every time a new standard is created, it gets imported into a DAWS system, and then we spit out all of the relevant requirements and links and everything else into a little standards pack. The second item on here is this QV requirements analysis tool. This has been a real godsend, and our requirements manager will tell you that she's spent endless hours in meeting rooms arguing with people about how a requirement should be worded, and this kind of takes that away. It takes that opinion away. So you set up your requirements, run this tool on them. It gives it a score out of 5, and tells you 5-star is, yep, you're cool, everything's good. If it's less than 5-star, it gives you a reason why if you've got too many bits to the requirement, if you're using words that are a bit fuzzy, like, minimum and, maybe and things like that. So it goes through and uses the rules from INCOSE. So INCOSE is a systems engineering organisation that have about 150 rules for writing requirements. So it goes through all those rules and makes sure your requirements don't break them. So that's a really good tool to be using. And it just helps keep you honest, I guess. So and we're even finding, although we're getting better, sometimes when you're drafting a requirement, it does come out as not 5 stars. So that makes us go back and have another look at it. And the last thing that I wanted to talk about was the RISB UK alignment. So some of the things that they draw upon in their strategy, they developed a strategy in November 2020 called the Rail Standards Strategy, and they had a lot of information in there about not just how to develop standards, but also a lot of other things about standards, how to use them and maintain them and things like that. These things that I've pulled out here are a lot of the things around the development of standards. So if you look at item 1, so to develop a whole system approach to standards, which is what we're trying to do. And by developing our systems definition document and defining the interfaces and the boundaries, signalling is a system, and we're trying to develop standards around that system. The second one is, again, is to implement a system definition approach. Okay, so we've done that, check. The next one, B2.2, is to implement a clear approach of linking requirements to objectives and rationale. So you can see there's common themes coming out here. And it was interesting that we started down the approach that we're taking, and then I saw this and went, oh, that's nice. We're all doing the same thing. B2.3, implement a clear and consistent set of application rules across documents. So that's really talking about templates. Make sure everybody uses the same templates so that you can see there's a consistent approach to the way the standards are developed and they look and feel. And all that helps the user. 3.1 is improve the content management of standards with more guidance of style, writing requirements, rationale. Again, rationale and guidance. So, making sure that we understand why the requirements are there. And the last one is really one of our key mantra, is to make sure that you understand how the standards are going to be used. So, I don't know that the previous set of standards that we have, or the current set of standards, really think about that. They think about what we need to think about from an asset perspective, but we don't actually think about, well, okay, if somebody has to use these, how are they going to use it? So we're trying to make sure that we consider that. And what we do, sort of before I look at finishing up, what we do is that a standard is not just a document anymore. So a standard that is an outcome, and it's a package of works. So it's not just the document, but it's all of the, like the QV Scribe report, for example, to say, yep, all our requirements are 5-star, or if they're not, here's a good acceptable, justification why they're not. Here's our systems specialty engineering report. So for every standard, we develop a specialty engineering report which says, okay, for each of the disciplines, this is what we did. This is the analysis that we performed. These are the conclusions we drew and what causes we have identified. And these are the mitigating requirements in the standard that help us mitigate these these causes. So, we have a systems engineering report. We then have a whole lot of traceability documents. So our traceability to RISB, our traceability to the RTOs, the traceability between the standard and all the causes. So you can see that in a nice succinct form in a traceability report. We also include an items to note. So one of the things that we found useful is that if we've made a decision along the way in the development of the standard, that we record that in an items to note register and explain why we've gone down that path, so that you can provide that to a reviewer and a developer of the project to say, well, we've gone down that path because we've been able to, do this, or we've used this direction. So it gives them a little bit more information. And I guess one of the things, so that's kind of the package. And one of the reasons that we've done all this is so that when projects are implementing these standards, which if you think about the users, that's the projects that deliver the new infrastructure, the new signalling systems, will be using these standards. They need to understand what they're trying to use and how to use it, but they also need to understand that if they can't deliver a particular requirement, that they understand as much about that requirement and why that requirement is there in the first place, so that they can provide a waiver against that with the right understanding. So if that requirement was there to mitigate a hazard, for example, they can, in that waiver, say, well, we're not implementing this requirement, but we are mitigating this hazard by doing X, Y, and Z. So it makes everybody's life a lot easier, and hopefully we will reduce the number of waivers that need to happen anyway, because we're providing, I guess, more rationalised requirements in our standards. Well, I think that's about all I wanted to say. So we're going to move on to questions in a moment, but what I just wanted to say with this is that we've been going for about 3 years now, and we've managed to produce all those foundation documents, and we've gone out to suppliers to get some work happening, and we've actually produced our first design standard, which is the Victorian Signalling Standard Signalling Principles, and that's now been approved, and we're looking for just the final tick off by DTP, and then that will become a new statewide standard, and then we need to work with the RTOs to integrate that into their SMS, so their safety management systems. So and we should be able to, now that we've learnt a lot along the way, we've got quite a few just like turning the sausage handle. We've got quite a few that are very close to coming out to industry review following on the back of this one. So there's been a lot of work, but we're now seeing the benefits, and I think we've got a lot of supporters from the RTOs in how we're presenting our standards and using this systems engineering approach. So thanks for your time, everyone.
Thank you very much, Jackie. We'll give you a little bit of break to catch your breath. I think you've got a bit of a cult following. There's over 200 people online, and some fantastic questions that we'll get to in a moment.
Awesome.
I guess I'm thinking personally about, well, RISBE's got a well-established standards development process that it's developed and evolved over the past 20 years. But we need to recognise sort of what we've done well, what can improve, and this has given me a few good insights. One of the common questions I have with RISBE standards is, how do we tease out innovation and not lowest common denominator is not a well-accepted term, and it's not accurate, but as I say, how do we tease out innovation? And one of the things for me is a bit of a test for that. I'm not sure if you have the same sign-off process, but in RISBE's case, we have a whole heap of criteria and other commentary around the development process, and one of them, it lists contentious issues. And for me, they're quite rare. And that's a bit of a warning sign for me that, gee, we're not prodding and probing enough if we're not getting contentious issues. So, and that's in a very, dare I say, manual approach. So with a more systematic approach like this, there is a danger, I guess, that there's not sufficient triggers to prod and probe. Would you care to comment on that around, well, how do you tease out innovative solutions to the problems you're trying to solve?
I think that I don't want to say we've had too many We've had lots of review comments. So when we first put the signalling principles out for industry review, we had over 1,200 comments, which was a challenge. But a lot of those were really good, resulted in really good discussions about what we should be doing going forwards. So we've had to establish that, okay, I know this is not what you're doing now, but do you think this is a good way going forward? Or we've had people challenge and say, well, this is what we do now, but we think that we should be doing this going forward. So we've had lots of that. And it's interesting that, so we've been able to resolve some of those, but even during our comment closeout, we found that there were still some sticky issues that required more than just a one-on-one to try and close out. So we've actually captured those in a change register for the next version, but we have about 25 to 30 of those that we need to resolve in the next version. And by calling in a number of signalling experts to be able to say, okay, well, this is how we're going to resolve this going forward. So I think by putting the rationale and guidance, it's kind of been a two-edged sword. So it's great, but then we've had lots of people go, yeah, but no, or this, or something else. So because we've got more information in there, I think we're getting more information back and more challenging. So I think that's a good thing.
How do you assess and mitigate risks when developing standards, particularly those relating to safety and security?
Yeah. So what we do is at the start of the development process, the first step is identifying the sources. So we've got a general scope of the standard before we start that development process at very high level, but at least gives us a starting point of what we're trying to help a user do, plus what we think the purpose and scope of the standard is supposed to be. Using that, we actually get a security discipline person to come and say, well, based on the scope of this standard, I think that we might need to do this type of security analysis. It's the same with all the other specialty engineering disciplines. And we record that to say, right, we think we're going to need to do this analysis. As we start to develop that standard, that analysis is performed. So maybe it's a physical standard and there's lots of physical security and they need to do a physical security assessment. And then as the standard develops, they do that assessment and see if there's any issues that may need resolving, given the scope of the standard as well. We've always got to make sure that we're thinking about the scope of this standard. But then they also look at the requirements that have been drafted at Bronze and look at, well, hang on, have you introduced any security issues in the requirements that are part of the standard now? And they do a further assessment on that. And then as they're identifying issues, we're recording them in our DAWS database and looking at introducing or pointing to existing requirements in the standard that mitigate the issues. So, and that's what I mean, we integrate along the way. And then as the standard goes from Bronze to Silver, we look at the changes and the security person looks at the changes to see whether there's been any change to introduce any new issues or any change to issues that they had previously identified along the way. And then we provide this linkage between the causes that can cause security issues to the mitigations in the actual standard itself. And that's the same for all of the specialty engineering disciplines.
Okay. This one should be an easy one. What was the original driver for introducing this change in standards development?
I think that it was that the current suite of standards wasn't suitable anymore. It wasn't able to be used. There was loads of input from the projects to say that the standards were really difficult to use. There was a lot of waivers, there was a lot of requests for informations coming across, and there was a lot of gaps in standards. So, and a lot of them haven't moved for the last sort of 6 or 7 years. So there was a driver to try and make that change.
Okay. your requirements management flowchart looks beautifully simple and elegant. You're not writing your own questions, are you?
No.
With the development of the new standards, will you be measuring the performance of standards somehow to see what their impact is and how they provide improvement over the previous standards?
It's a good question. I'm not sure how you exactly do that, but what we would like to do, so in our schema, our requirements schema, there's also a place for waivers and change proposals. So what we'd like to do with all our standards going forwards is say, is when we get a waiver against a standard is to link that. And also when we get a change proposal against a standard is to link that as well. So we can see how many waivers we're getting against certain standards or requirements in standards, how many change proposals we're getting as well, and things like that. So we can look at the trending data to see, okay, well, hang on, this particular standard, in this section has got loads of waivers. So obviously we haven't really done or provided enough detail or enough context to the requirements for the users to be able to do that, or the requirements just aren't. Perhaps they're of the wrong flavour and they're not able to be implemented well. So we do want to do that so that we can start recording how many of, what part of standards industry projects having trouble implementing, because until you start doing that, you really don't know how good your standards are. So if you've got a standard that, I don't know that we know now, but I mean, somebody would know how many waivers there are, but unless you can actually draw that data out of something, you can't tell, how industry is complying with that standard, because let's be frank, a standard isn't worth the paper it's written on unless it's implemented. So that's how we'll measure the performance. I don't know how we can compare it against previous performance because I don't think they have that data.
Yeah, I guess just thinking out aloud, you could have a measure around the standard around the cost to implement, the ease to implement, facilitating safe outcomes and so forth, which could be quite subjective, but at least there's some measures. But as you say, compared to the past, we haven't had that systemic approach to really measure against. It's an interesting question. Can you share an example, in your view, where a systems engineering approach has standards development has significantly improved system performance or user satisfaction? I mean, it might be a little bit early, I guess, but
yeah.
Are there any sort of gold moments that you thought, gee, this process that we're using in the old, as compared to the old process, has drawn out some things that we would never have identified? Any light bulb moments for you?
Yeah,
or your
no,
team?
I don't know that there's anything in particular, but I do know that the RTOs in their review have said how it really does help them understand the requirements with giving the rationale and the guidance. I'm just trying to think of, we had so many discussions about approach locking timers, and the fact that there isn't much in the existing standard. There was quite a few people going like hallelujah. We're actually teasing this out and putting why we need this as opposed to that. And we've had like independent reviewers come back with those comments as well. So approach locking timers were probably a big thing. Because they were a gap in the existing set of standards, so it was a bit hard to tease out. The other thing that's been interesting is trying to reverse engineer some of the standards that some of the requirements in the standards that are existing in the RTOs. So some of them we went, well, we don't actually agree with that number, so we're going to provide you with a different number and give you a rationale and let you argue, because we've said, like, argue with the rationale, like if the rationale's not right. And, we've managed to change, the number on a couple of things. So it's been an interesting journey with the RTOs.
And look, my guess is you wouldn't suggest you've nailed this completely and now got a perfect model. But you've come an enormous way from the traditional, dare I say, the traditional approaches that aren't systematic. Each of the standards development organisations go about their work in at least a little different way, and this is now, only my own personal reflection, a great opportunity to rethink the way we go about stuff. And again, we talk about the current environment, window of opportunity, a lot of emphasis on interoperability. I think, again, I can only talk from RISBE's perspective, a great opportunity to revisit the way we go about this work so that we are drawing out the true requirements and the true opportunities, and doing it in a very systematic and defendable way. I'll just finish off with one more from your fan club. Thanks, Jackie. Great presentation, a refreshing approach to standards development. This high level of rigour and process means standards do become standard in how to write standards, how to interpret standards, and how to understand standards, and that all the required ground has been covered. Excellent work, great example, we could all follow. Thanks. Look, as I said, from RISBE's perspective, we're reviewing the way we go about our work, and this is going to be some great reference material for us to think about. And I know other standards organisations that we're working with are doing similar work. So look, really appreciate the time you've made available today. We've got a few more questions there, but we'll circle back with you out of session if you like, and then we can we can provide them on answers to that online.
Sure.
But thank you again for the work you've been doing with your team and sharing, making the time and effort to